My name is Craig Gardner. I work at SUSE, and I've always thought that I might be a pretty good LAMP developer, but you know, I've got the L part down pretty darn good. But I prefer Moin Moin and Leidy, and I really don't like MySQL. I'm more of a Postgres guy. And as far as PHP is concerned, oh, it's awful. I can't stand it. I prefer Ruby and Rails. So I just kind of fail on 3/4 of that case there. But nevertheless, I'm a software engineer and have been working at Novell and SUSE for the last 17 years. I started my Linux journey about nearly 20 years ago in 1994, about the same time that Dorian did, on Slackware, and have enjoyed development and using Linux for all that time. And along the way, I've been involved in a number of endeavors and software projects that have had a lot to do with the securing, and both in terms of writing secure software, but the topic that we have today is in terms of implementing secure practices in the Linux operating environment. And I do work for SUSE, as I've already mentioned. I love SUSE. I'm very passionate about SUSE, but that doesn't mean that I'm exclusive of the other Linux variants, which I have great appreciation for, Fedora and Red Hat and Debian, Ubuntu. And I would like to stage what I have, the information that I have for the slides today, in the context of the slides, the screen captures that I have from a SUSE Linux perspective, but by no means should you think that I'm trying to push a SUSE approach on this. This is a presentation that contains some universal information. I want you to be thinking about the concepts and the principles that are involved, and that transcends whichever Linux distribution that we're talking about. And if I could, I've got a pretty good idea right here. But generally, when I give this presentation, which I matter of fact, just got back from a conference giving this particular presentation, I always have to get my bearings as to who I have in the room, because there are typically two populations of people that come to this kind of a presentation. Those who are administrators, those who are policy makers, those who are the CIOs or the security admin that exists in the company. And then you have those that are the system administrators down in the trenches that have to implement all of the nonsense that the guys up on top are trying to say are important. So knowing now what you've all told me here, I suspect that most of you, or if not all of you, are the latter and not the security policy makers, which makes the conversation that we have today so much easier. I might have asked you to sit on opposite sides of the room so that we didn't have any clashes that would take place if that were the case. But I mean no offense to those who create policies, because that's a very important thing. That's a tremendously valuable aspect to having a secure organization and a secure operating environment, is to have someone making good decisions about security and making sure that those security policies are adhered to and administered properly. But sometimes some not so practical details creep into those policies. And we won't be talking about those in any detail at all. As I mentioned, I've misplaced my clicker from this conference that I went to, but I'll use my old-fashioned pressing of the space bar. What I want to do is talk to you today about the what's and whys about security, and then to talk about the details of what goes into having a secure operating environment, and then talk about some tools that can help you to do that. Now, we'll be talking in the context of a server. Nowadays, it's not enough. We've got hundreds, sometimes thousands of servers that we have to administer, and to have some confidence that they are being administered securely. The scope of this discussion that we're having today was not to discuss how to deploy security practices throughout a large data center organization. I'm sorry, but we can have that kind of a discussion some other time. But this today is just to talk about some of the individual principles that certainly are beneficial as you go through a larger scale deployment of security practices. But this is to open your thoughts, your minds about things that you should be considering when you are the guy in the trenches trying to keep your system secure. And it's also important to note that, I've already said enough about that, so I'll just move on to this next slide. So what should security be? My very well-respected colleague, who's the security architect in my company, is by the name of Roman Drahtmuller, who is a good friend of mine. This is a fond couplet of sayings here that he uses quite often and that I use in my presentation, that good software does what you expect it to do and does it well. And then secure software encompasses what is stated above. Secure software is quality software that does nothing else. And that's a challenge because by the very definition of software, software has bugs. It has shortcomings. And those shortcomings that take place, that occur during the engineering process, that perhaps are missed by the engineer and the testing organization and that enter the wild into your operating environment, sometimes result in malfunctions and crashes and downtime and all sorts of pain and anguish. But that's also not precisely what we're talking about today. Occasionally, the shortcomings of the engineering process result in security vulnerabilities that can open you up to having your data, your intellectual property, your hard work compromised, lost, exploited for competitors' practices. And having a secure environment is critically important to the operation of your business. Your business depends on having a secure operating environment. You don't want to lose your data. You want to have integrity in your operating environment. And that leads us to making sure that you apply your maintenance updates. The application of your maintenance updates will also result in the correction of those black items listed at the top. But the most critical aspect of this is to make sure that when you have a security patch that is released by your distribution vendor, that you are applying it as quickly, as effectively and efficiently as you possibly can, which is not always easy in today's business environment. Sometimes you are very restricted in the windows in which that you can perform maintenance on your server. It's a difficult thing. Nevertheless, if you find yourself in a position that a 0-day vulnerability takes place, and the world knows about the exploit to the software that you haven't patched yet, the pain and the expense, the risk that's involved is far greater than the challenge of managing a maintenance window. If you have difficulty convincing your organization to apply security updates outside of your normal maintenance windows, talk to us, talk to the vendor of your security, of your Linux distribution, and ask for help convincing your management that this is critically important to the integrity of your business. We're happy to help. We want to have those conversations with your business executives. Nevertheless, if they're out there and you have the opportunity and you're not applying them, then the fault, of course, is yours. Make sure you're aware of what's going on with the security updates that are available to you. Get them applied as quickly as possible. In terms of open source, and of course Linux being extraordinarily open source, a champion of open source, there are often times that people panic, or they at least are concerned that I'm going to apply a maintenance update that may be taking me out of the frying pan and into the fire, making my runtime environment less secure or more subject to other kinds of failures. With the kind of development that goes into open source, yes, there is that risk. That risk does exist, that things bad things can be exchanged for worse things. But because of the development model that exists in open source and in Linux, the greater number of eyes that exist and the greater number of fingers and very intelligent minds that are involved across the great expanse of the many projects that exist in Linux, your risk is far less by applying new updates than running in the existing vulnerable condition. Is that fair to say? Thank you. So, a closer look. we could talk for a great long time about a variety of different aspects of having a secure running environment. Administration details, all of the things that you would consider for your network or your other infrastructure considerations, zoning, that sort of thing, but that's not what we have time to talk about today. We're going to concentrate on the bottom item there, that is deployment, installation, configuration, auditing, all those kinds of things. And we won't drill down on all of these in detail, but that's the category of information that we'll exchange today. So let's talk about planning and the configuration and the hardening of your system. I have a little diagram here that may not look precisely like yours, but it's a representative diagram that may approximate what your environment looks like. The thing I want to focus on is this green circle down here. Many times we will take a server and we will, without much planning, without much forethought, just knowing a small set of parameters of what we want to do with that server, we will immediately put it into our production network or even out into the DMZ. This administrative network that exists here is where you get to play, and you get to plan, and you get to experiment and get that server the way it's supposed to be, the way that you want it to be, the way that will be the most effective for you, without endangering all the rest of the things that are going on in your production network or in the DMZ. You have the opportunity to break stuff, which sometimes can be fun. And the ability to perform Nmap scans on your system without having the rest of your network administration pick up the phone and call you and say, hey, who's scanning this stuff on the network, and get all angry with you, and then you get on report and then you get fired and all those kinds of things. We don't want any of that stuff to happen. Plus, of course, any damage that you do to your infrastructure, to your systems, can be very easily isolated. And of course, if you're running here in your administrative network, it's much easier for you to keep track of your MP3 collection that's there and not have anybody mess around with what's going on there, which is always very important. So put together an admin network, an isolated bit of the network that gives you confidence that you can set things up right before you put them into production. Now, this is a screen. This is in the context of a SUSE installation, but I want you to think of this more universally here. This is the first kind of thing that you will do when you're actually installing a system, is that you have made some package selections, and all of the packages are getting installed. So what kinds of things should you be thinking about? What sorts of security considerations are involved in your package selection? Any ideas, any thoughts you want to share? Yes?
What ports need to be open or closed?
Okay, that's a great one. That's a very excellent question. Now, I will actually defer that to a later screen and a variety of other conversations, because ports are critically important. That's definitely true. But that is parenthetical to the package selection. Certainly you would know that if I'm installing the Apache package, that you are going to be, it's implied that you're going to have port 80 and 443 opened. So certainly involved, yes. Any other thoughts? Yes, Dorian.
So you don't install packages if you're not going to use the software.
Bingo.
Yeah.
That's critical right there. And that's the main takeaway from this particular slide. Only install the software that you intend to use. Don't install other packages if you don't intend to use it, because it's just an accident waiting to happen. It's a security vulnerability that's in embryo that will take place later on. Yes, another thought, Steve?
I was going to say, I remember I think I got into Linux probably, it was after my mission. It was like the Red Hat 6 had just barely came out. But I remember a lot of people had Red Hat 5.2, or I think it was. And up until then, by default, it had POP2 installed, a POP2 server.
Ouch.
Which nobody had used for a couple decades.
Right.
That's the kind of thing that, things that are installed by default that, they're a lot better about them now than they were back then. But
definitely.
there's still stuff, I installed, using Red Hat, and if it, the amount of effort it takes to convince it that I don't want Bluetooth on my server, or Abahi or some of the other,
Yep.
I don't need the UPnP stuff going on,
Absolutely.
These are things I don't need on my network. And so
you want just enough of the operating system to do what you need it to do and nothing more. Another thing to consider, along that line before I move on to the other thing to consider, is there's a balance to strike here. Large numbers of packages are still necessary for a just enough operating system. Do you need to go through every last package and know every last detail of every last file and every last port and every last SUID bit that's going to be set on everything that's going on with every package? Well, perhaps you do, depending on the risk that you're willing to take and the business that you work for and the kinds of business that your business runs. Sure, that's a possibility, but that's certainly not necessary for the vast majority of circumstances. But to have a general idea of what you have is at least a bare minimum of the kind of consideration that you have.
I would at least look at, after your install is done, I would look at the services that are running, or the services that are installed, even if they don't get turned on by default. That's a good place to start. Do you have port map installed and you don't need?
Yep.
You're not running NFS, so you don't need it. Things like that. And so what I'll do generally is I'll do the minimal install that it lets me, and then I'll figure out what it installed anyway.
Great approach.
And then start, what can I remove, get that stuff off, find what packages those come in and start removing those packages.
So from my perspective, in a reasonably secure environment, you're basically only going to have 3 ports that are going to be open when you have a system installed that are the bare minimum that are the baseline from which you may, such as Apache, add to. Number 1, port mapper, RPC. That needs to be there if you want to have any sort of API calls from in and outside of the box. You need to have SSH port open, and again, this is the third one's kind of a soft one. It just depends on what you're doing in your operating environment. But the SIMOM listener, typically, if you're going to be doing any sort of remote administration, you want to have SIM installed. If you're listening, if you're not going to be using SIM, then there's not even any reason to have that. But if you're going to be administrating the box, you need to have SSH installed and listening. And if you're going to be doing any sort of API calls in and out of the box, you've got to have RPC running. Now, that other consideration that I was mentioning earlier that doesn't exactly... Oh, sorry, it is. It's got this information here up at the top. I forgot which screen I was looking at. You have the installation source. You need to install from a source that you trust. You need to make sure that you know that that source contains that CD or that ISO image, that network installation that you have where you're installing from is a place that you trust, because so often the easiest way to subvert any security on a system is to subvert it from the original OS installation. If someone can get into your installation media and you're not checking for signatures of the RPM of the packages, regardless if it's RPM or the depackaged packages, then you're in trouble. You've got the possibility to have your system compromised even before you've booted the kernel. Okay, enough about that screen. Next one. Again, these are just principles that we're talking about. This is a screen during the SUSE installation process where they ask you for how you want to manage your passwords. This is a SUSE Linux Enterprise installation, and it has, if you can't see terribly well from the back, it has 3 options that you can select from. There are actually some other options that you can select from Expert, but there are 3 default ones. The top one being DES, second one being MD5, and the last one being Blowfish. So are these reasonable choices in your opinion, or are there better choices that you could have? Yes, Alfie.
My understanding that the best option right now is something called test script.
Really? I'm not familiar with that. What test script you said?
Yeah, script, yeah.
Oh, S script. Oh, I'm sorry. I thought you said test script. Yes. or related to script SHA-256, SHA-512. So for this operating environment, Blowfish is decent, but it's not the very best that you could have. Are there reasons why you would not go?
Some people argue that Blowfish is better than. But is it
Valid
Blowfish
argument.
or bcrypt? It's based on Blowfish.
It's based on Blowfish, and so I think it's just doubled the length in terms of bcrypt over Blowfish. I would characterize SHA as being slightly better, but when you're talking about large percentages and CPU capabilities and large memory to crack passwords, there would be effectively a very insignificant standard deviation between how you would be able to decrypt either one of those. So.
Well, bcrypt uses Blowfish, but it does things to basically it causes it to take longer
right
to run, so that it's harder to brute force.
And that's precisely what we're talking about here is the brute forcing capabilities.
I don't know if that's Blowfish. If that's just straight Blowfish, then it has no real advantage over.
Correct.
SHA.
Correct. So would there be reasons not to use MD5? Depending on your environment, MD5 might be sufficient. I wouldn't trust MD5. MD5 is very rudimentary and very difficult, not very difficult anymore to brute force. It really can be done in a matter of minutes with today's computing processing power. But why do you suppose we put something like DES on there? Is there a reason why DES is still a valid, potentially valid option?
History.
Well, yes, history. But what is the history, perhaps, that we're talking about?
It's been used in the past. And, you might have to have your passwords encrypted, so that something that was in the past can read them. So.
If you are still in a Unix environment, if you are still trying to connect with NIS or YP to Solaris boxes, they don't speak MD5. They don't speak Blowfish or any of the other advanced encryption algorithms. They will only speak DES. So that's a tremendous risk, but perhaps it's a risk you're willing to manage because you are in an environment where you're using NIS or YP. Good. So that's a good discussion about passwords. Now we could also talk about password length and password expiration. And well, we'll run short on time if we dive too deep in those kinds of things. Sean?
I was going to say, I don't know if anyone cares, but I understand the Adobe hack where they got the password lists.
Yeah.
That was DES.
Triple DES.
Yeah.
They were salted triple DES, but they're being
No, they
cracked.
weren't salted.
No, they were salted.
No, because everyone had the same. If you and I had the same password, it showed up the same.
Means we have the same salt.
They had the same salt, which is not
They only
uncommon.
Okay, so they use the same salt for everybody.
Yeah.
Yep.
Same salt for everyone. Has
They
triple
also
DES.
they didn't do cipher block chaining so that the first 8 characters, if the second 8 characters of my password were the same as the first 8 characters of yours, they would make the same. They would come out the same. Just in the different block. Anyway.
So that's a reason to think about DES.
Yes. So one common implementation of password formats exists today about saying you need to have at least 6 alphanumeric characters. I'm sorry, 6 alpha characters, 1 numeric character, and 1 special character. Is that more secure or less secure than a variable length password that has no alphanumeric special character limitations? Any thoughts?
Well, the longer the password, the better.
I agree with that. Except in the case where you're doing simple dictionary words, yes.
Right.
Yes. It's strange that when you actually limit the number of alpha characters and impose numeric characters and special characters, you're actually reducing dramatically the pool of possibilities that you have for a password. Whereas a variable length password with no limitations, of course with common sense deployed or used, you can have far better, far more secure passwords, as long as the person generating the password understands that using simple dictionary words is not necessarily a smart thing. But where and how you combine those things, having that flexibility creates for a stronger password. Does that make sense? Okay, next slide. We're going to skip this because we're going to run out of time. This is far more interesting. Okay, so this is, again, a SELinux Enterprise installation here where you can make some selections. Up at the top, it talks about network settings. It has the network mode. So for this case, it's using net control with the if-up scripts. It has IPv6 protocol is enabled. Here we have a screen about firewall, including opening the SSH port, have network information, DSL, blah, 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 and proxy, VNC remote. What are some things that on this screen would cause you to stop, think, plan, and implement things a little differently if you had your high security hat on? Sean.
In my environment, I turn off IPv6.
Absolutely. If you are not planning to use IPv6, don't leave it running. Don't even enable it, because that's a vulnerability waiting to happen. If you're using IPv6, great, leave it on. But you're far more likely to have an infrastructure and an implementation of IPv6 throughout your network that will make sure that it's a little more secure. Leaving it open where no one in your network has done any configuration for IPv6, you are an open target for hacking. Understand that? Turn it off, unless you're going to use it. How about firewall? Who in here enables their firewall? Raise your hand. Oh, come on, everybody.
On the server?
Yeah.
Firewall.
Well, of course you would, yeah. You have a network firewall, yes. On a server, who in here would enable the firewall? Sean, why would you not enable your firewall?
Well, in my experience, I've had too much time, or too many difficulties. I'm not the admin. And I get tired of telling the admin, I can't connect to this. I can't. I'm trying to do a ping scan, and I don't want to use TCP. Open up so I can get there and turn it off. We've got the next generation firewalls blocking everything.
On the outside.
No one's going to connect this from outside. It's not connected to the network. This is just internal only. Please let me in.
Gotcha. So good. You're in a more of a development environment, and you're not quite so concerned about those kind of firewall things, and it impedes your ability to do what it is that you're trying to do. That's a good answer. I like that. I'm kind of partial to making kind of a disruptive statement of turning that off, because it gives you a little bit of a false sense of security. Now, bear in mind that NetFilter is a good way of logging data of who might be trying to do something to your box, innocent or not. And there are benefits to using NetFilter. There are benefits to having this firewall enabled. But generally speaking, it doesn't make your system more secure. As long as you know what ports you intend to have open, and those are the only ports that are open, your system is just as secure as if you had used a firewall to do that. Open only the ports that you intend to use and verify that those are the ports that are open, and there's no reason for a firewall. Now, that's kind of a contentious thought.
There has been malware that opens up ports on its own. In addition, if you use what you're getting by default is just blocking incoming connections. If you have your firewall really set up properly, you're also blocking outgoing connections that don't need to happen.
That is true.
And that can be very valuable in blocking, if someone gets in, because usually with malware, the first thing they do is try to download the rest of it, because they just got a little bit in, a little piece, and they need to download the rest of it. And having that blocked,
depending on what malware is installed, if your system is compromised, it may be only a matter of time before they've gotten it beyond that anyway.
The type of stuff, a lot of the malware, a lot of the ways that people do the exploits, they just get a teeny, just get a little bit in, and then they need to pull in the rest.
Right.
In order to really, they just want to get that wedge in, and then they exploit it. So anything you can do to make their job harder is valuable.
Fair enough. And I'm not one to argue. If you want your firewall on, I'm not going to be able to convince you of that. But I do want you to consider what exactly is happening with your firewall, what it is that it's doing for you, how it may be helping you, and it may be overhead that's not necessary and that might be doing you a disservice if you're trusting what the firewall is doing without understanding all of the other details of managing your open ports and the services listing on those ports. Then you've missed a great opportunity to keep your system secure. But I accept your argument, Steve. Yes?
What about something like SELinux, or is that similar to what you're...
That's great. And we will talk more about the kernel containment in a little bit. Thank you very much. VNC, remote administration, by default in a SUSE context, that's turned off. That may be a convenience for you. If you turn it on, if that's the way you're going to do your administration, then that's great. But that is opening up a little bit more of a vulnerability to people intercepting the management activities that are going on to this particular server over VNC. And likewise, if you're not going to be using the proxy, turn it off. Don't leave it on. There's no reason to have that on. All right, what's my next slide? Good. So in all three of the major variants that I deal with, the Red Hat, the Debians, and the SUSEs here, we also have the ability to act as a certificate management system, which gives you some capability of some confidence with SSL that what it is that's acting on your server has some encryption that's associated with it. So we're not going to dive down into this particular detail here. It's a little bit of a red herring in giving you some false sense of security, but it's not a bad thing at all. It's a good thing for you to have if you're using it. And most times, this particular CA management system is not going to be, if you're going to be using CA management across your servers, you're probably better off purchasing a commercial product that can give you root key, the specific root CA keys that have signed your certificates rather than just one that's self-signed here on your system. But the reason we have this, of course, LDAP. If you're going to be using LDAP, by all means, enable it. But if you're not using LDAP, turn it off or it's a security vulnerability. The last one here is what I was talking about earlier in terms of SIM. And so many of our operating environments across so many different vendors take great advantage of this. If you're using it, keep it open. If you're not, if nothing is using SIM, turn it off. Good. What's this page? Okay, so in SUSE-Linux, we have what's called the, it's actually on the next slide, the Linux Security Center. And it allows you to go through in a comprehensive way a list of security considerations for that particular server and questions that you should be asking yourself and recommended settings that we would give you as the vendor of this particular distribution for each of those different settings, plus some helpful information. This is in YAST in SUSE-Linux, and there are similar guidelines that exist both for Ubuntu and for both Red Hat and Fedora. But we put it together in this nice screen here to help walk you through it. It has a columnar arrangement here, a nice table. The top here says security settings for each of those different recommendations, each of those different categories. And then the status of that particular setting as it currently exists for you on this server. And then the recommended setting for it in terms of a graphical representation to make you understand that you're meeting what we think is the more secure setting. So green check mark means yes, we think that that's the more secure setting, and red is that your state, the state of your server is less than secure according to our recommendations. And then the most helpful thing is, of course, each one of these items has a link that you can click on to learn more about each of the individual settings. So, for example, disable remote access to the X server. Our recommendation is to turn that off. If it's turned off, then there's less opportunity for a remote user to compromise your system, project X back to his X server, and be able to control your system. And in this case, it's disabled, and that's our recommended setting. Or like the top one of using magic syskeys. Has anybody used magic syskeys? Are you guys good sysadmins and know what that is? So you have the ability in Linux to send direct keystrokes to the kernel to do a variety of different things, such as not just from user space, but using the syskeys to send a direct call, syscall, to the kernel to flush the disk buffers, to reboot the system, those kinds of things. Now, sysrec keys are extraordinarily helpful for a system administrator, or even for an engineer who's developing an application and gets some buffer overrun somewhere, hoses a system, and just needs to reboot it without having to press the power switch or something like that. There's a lot of very helpful behaviors with sysrec keys. But if you have those open and someone compromises your system and they can send sysrec keys, then it wreaks havoc on your operating environment. You don't want that. So we would recommend that you turn that off. That is to say, your system is more secure if you are not using that capability of the kernel. So you choose, and you can see what our recommended setting is. There are a lot of other settings here in this security center, such as predefined security configurations, password settings, boot settings, a variety of things here on that navigation pane that will help guide you through more and less secure settings for your system. And then related to that sysrec keys conversation here, when we talk about Linux, we have, and basically every operating system is characterized very similar to this, and Windows looks almost exactly like this. But the real important characteristic that we represent here is that black line there separating the kernel space from the user space. And the more integrity that your kernel has, the more secure your system is. This black line helps to reduce the amount of disruption that can go on with your system. As long as user space can only affect other user processes and cannot interrupt what's going on in the IP stack or with the disk devices or with memory, then you have a fairly secure system. And you have well-defined APIs that will be called to interact with those resources that exist within the kernel. Now, there are ways of compromising those syscalls, but good software engineers and good Linux kernel programmers have done a great deal to try to reduce the risk and narrow the possibility of compromising those APIs, those calls down into the kernel. But suppose you have a kernel module that you want to load, and you don't know where that kernel module came from. You don't know who built it, you haven't seen the source code, but you've got it because you think it's going to provide for you some functionality that you want. The moment that you, as root, place that kernel module into the kernel, you've now have possibly completely opened up your operating environment to exploit. So you need to be very careful and mindful about what it is that you're allowing to run in kernel space, and know where your kernel modules are coming from. So, trying to rapidly go through the next few slides and then allow you to ask some questions. And if you do have questions here, I'm certainly happy to have you interrupt me. To get to where you have greater confidence in your operating environment on this server, you need to think like a hacker. You need to think differently than you normally do. Usually you are this benevolent system administrator who wants people to use your services and to get all of the benefit from the system that you are providing. And that's good and that's right. But you need to also be thinking in terms of how might those hackers be trying, how might people who don't have my company's best interests in mind and don't have my livelihood's best interests in mind going to try to compromise this server. And we look at it as sort of an outside-in perspective, starting with the network and moving through these different categories of things till we reach the kernel. So let's talk about each one of these as we go, starting first with network. So as we mentioned earlier in the discussion, Sean mentioned that he had the great idea to turn off IPv6. You definitely want to do that unless you're going to be using it. But more specifically, you need to be thinking about physical access to this server. If you leave an interface open, enabled on your system, even though it's empty and has no network connection connected to it, if it is in its default state, it probably is going to get an address with DHCP. And anybody who has physical access to that box can plug into it and can very easily now attack your system through that port. If you're not using the port, turn it off. Disable it entirely. And of course, know where your cables are going, which is not easy. IP forwarding. You may think that oh, my system is secure, no one's going to be hacking my system. But if you have IP forwarding turned on when you don't intend to, now you're a very loving hop for a security exploit to facilitate a potential hacker going across your host back to another host and compromising one that perhaps is not as secure as yours. So if you have no intention of forwarding IP, turn it off. We talked a little bit earlier about net filter, about, I was going to say IP chains. Boy, that's embarrassing. Anyway, turn off your net filter, maybe. That's up to you. But my recommendation is to know what's going on with that. We'll get into that, one more example of that as we get to the next slide. One interesting thing that you might do is maintain a record of your ARP tables. Everybody know what ARP tables are? So you have a table on your system that maps the IP addresses that are known with the MAC addresses that are known that have connected to this box. From time to time, you might take a snapshot of your ARP tables and keep a file of that. Maybe keep an off-site file of that. Spool that off to a remote server somewhere. And then if you ever see an IP address that you don't recognize, you have a nice comparison that you can make and have an idea that someone is compromising your system. It doesn't always mean that someone's hacking you, but it's information that's useful to you. And in to the tune of information that is helpful to you, these particular tweakable things that I have listed here aren't necessarily things that are going to make your system more secure, but they are technologies and protocols that and considerations that you should make to help you analyze what's going on, that may help you to prevent a denial of service attack, like congestion. What's ECN? Congestion notification is what it is, that allows you to have host A and host B send packets across a congested network to give you a report of what it saw, what the packet itself saw in terms of congestion, so that you know, is this legitimate traffic that's going on that is causing you to have a network disruption, or is this somebody that's launching a big, huge packet spam attack on you? So a variety of things that you can do to measure, analyze, give you more information about what's going on at the network level. The next slide, we talk about ports. This is where I say that you can get the greatest benefit by simply turning off your IP tables net filter. Find a box in that green, remember that green admin network that you have set up in your environment now? Take the box in there, run nmap on it, and that'll report to you all of the ports that are open on the outside. Then log into the box and run netstat from inside and see what ports from the inside appear to be open. If there are any discrepancies between what's perceived to be open on the outside and what's perceived to be open on the inside, you have some work to do to reconcile those differences. Once you have them matching, you can be pretty content that I only have open those ports that I intend to have open, and therefore only the services listening that I intend to have listening. Fewer security vulnerabilities, and not any worries about preconceived vendor notion of what should be open from the net filter perspective. Not that that's bad. And of course, don't forget that we're not just talking about TCP, you also have to have considerations for UDP. And then we already talked about IPv6. Oh, here's another interesting thing. Bear in mind also that not all services run in user space. The example I have here is NFS. The most ubiquitous, the most abundant deployment of NFS is the normal user space NFS. But there's also a kernel NFS package that you can download and install and run that is more efficient because it's running in kernel space rather than in user space, but now is, and actually has some different functionality, which is pretty cool. But it's a liability because now you have direct access over NFS to the kernel space. Possible security vulnerability. Okay, now stepping up to the next level, stepping down to the next layer, services. We mentioned all, you guys had great answers for that. Disable the services that are not needed. In fact, don't even install the package, or if it's there and you don't need it anymore, then remove the package from the system. This can be a little bit of a problem when you have clever packagers who have lots of clever package dependencies. Maybe you have removed Apache because you don't want Apache running on your system, but then you install package foo that depends on Apache, pulls it in, and might even cleverly install and run and listen as Apache on the system. So you have to be careful of those kinds of packages that start services for you. When you're going through the process of removing the software, disabling services, you can use intserv to remove it, or anybody else use systemd? Systemd is popular yet? Shh. We'll see. That's coming. Anyway, remove that. Kill the service, whether you're using the init scripts or systemd, however it is that you're going to do it. But don't take this for granted. Actually look at the process list. Actually look at your netstat output and verify that it's actually dead, gone, no longer there. Because sometimes processes don't really die when you use the standard mechanisms for doing that. You may have to kill it. Good. Now down to the process level. Get to know the processes on your system. So for some sysadmins, they have these photographic memories and they know exactly what's running. And they see this one line in their PS output, and that's not necessarily me. That's kind of a challenging thing for me. But you should get to the point where you've got a pretty good idea of all of the different processes that are running so that you could see, hey, I don't recognize that thing that's running. I wonder what that is. And of course, you could query your package system and say, well, I see this NSCD thing. What is that? And asking the database will give you some information about that particular process. You have a better idea of whether it really should be there or not. And then, of course, one of the most effective ways to find out if a service really is needed on a box is to kill it and wait for the phone to ring. Sometimes not the most effective way, not the most polite way of doing that. Okay, now at the file level. In SUSE Linux, and I'm sorry, this is a space that I don't know very well in terms of Fedora and Ubuntu. But the principle, again, will apply as we go along here. From a SUSE perspective, we have this permissions file, which gives you a comprehensive list of what processes, what files should be given SUID rights. And that by running this permissions tool will reset all of those things whenever you want it to. You could like cron a job that every day or maybe every hour if you were really anally retentive, you could reset all those things. So in case some renegade hacker comes in and is able to set UID on a file so he can run a whole bunch of things in privileged mode, you can run this and it will reset anything that it doesn't recognize as being authorized, a whitelist of those things that should have SUID, and remove the bit. Helpful. You can also do the same thing, and not just by blanket resetting all that. You can have a report generated with checkstat that tells you, hey, these things aren't on the whitelist and they are set UID, and that's a problem. A variety of things that you can do with RPM itself allows you to keep track of the validity of all the files that you have on your system. Every time you install a package with RPM, it keeps all of the metadata about each of those files in its comprehensive database. It can get lengthy and verbose, but you could keep occasional off-site backups of that RPM metadata, the whole database, and occasionally do a diff on what you have stored off-site with what you have running today and see if there's anything funny going on. Even more helpful, though, is this advanced intrusion detection environment that exists called AID that does all that comparison stuff for you comprehensively. AID is pretty cool. It's not necessarily for everybody, but that's a really good tool for managing all of the file permissions that exist on the system. Also, keep an off-site copy of your AID data, and that will help you when times get tough and you can't remember what's supposed to be going on. Look at that AID database. You can see, yes, that's where this hacking event is taking place. Perhaps even keep off-site copies of information about what's mounted and how it's mounted. That's helpful. The kernel, you asked Mr. Tolman. Tolman, is that right? Yes. Earlier about SELinux. SELinux was a tremendously powerful tool that contains running processes according to a very precise set of rules. It says that certain things can run, it has a whitelist of those things can run, and everything else is blacklisted. There's also now a little more modern technology that exists called AppArmor. That doesn't invalidate SELinux. SELinux is also incredibly important. It's still apropos today. But both AppArmor and SELinux are available to you as options to have runtime environments contained so that they can't get out and destroy, damage, explore other parts of disk, other parts of memory that you do not authorize it to do. SELinux is generally viewed as being more difficult, challenging, more complex, which also gives it more power and more flexibility if you know how to use it. But the complexity often gets in the way, and if you implement it incorrectly, you end up with a less secure system than when you started. So you have to be careful in that regard. Nevertheless, it's powerful, good, valid. AppArmor does things just a little bit differently, where you it's still the same. In the interest of time, it's still principally the same. You're doing containment of the environment, but it's a little easier to implement. The syntax, I have an example that's on here, gives you an idea of this DHCP daemon that has these particular rights for each of the different files that exist, and these capabilities for each of for the entirety of the operating environment. The cheroot, if you will. It's not really a cheroot, but commonly similar to a cheroot environment of how it is contained. This will keep your kernel safer and prevent exploits in the kernel space and in user space. It reduces the amount of exploitation that takes place. Okay, should you use... Oh, I just talked about this. There is no golden hammer for this kind of stuff. There is no one tool that does everything perfectly. It's you deciding what you need, what's best for your environment, and then implementing it in a conscientious, thoughtful way. All right, so more about tools. Again, this is intended to be a universal approach to these kinds of tools and not a vendor-specific thing, so I've got slides for each one of them. From a SUSE perspective, you've got that security center that walks you through all of those security considerations. You have a profile generator for AppArmor that helps guide you through creating an AppArmor profile that will be effective for the application that you are trying to run and contain. We talked about AID and RPM. We also have Nmap, which is the way that you would scan the individual server for all of the different ports that are open. And there's also a way of looking for not just open ports, but general vulnerabilities on a system from an external perspective that we would encourage you to use OpenSCAP with these OVAL templates that are becoming more and more standardized and employed in a they're really enterprise oriented, but there are more open source and more enthusiast oriented templates that exist that can be helpful to you. Notice that I have down at the bottom a long URL that you're not going to be able to write down here, but I have it on my slides that I used for OpenWest, and I can certainly share them here for plug. But that's the hardening guide that talks about a lot of the things that I've talked about and more. Not just SUSE, we have Ubuntu. Ubuntu has a very nice online forum, documented data, questions and answers that take place, real-life people that can address your concerns about security in their environment. And there's the URL to the forums. They have their basic security guide, which I have on here. They also do their user space isolation with AppArmor the same way that SUSE does. They also highly recommend that you use AID, although they don't have the RPM database that they can use, and that's really a bummer when it comes to Ubuntu. The packaging mechanism doesn't have that same capability that RPM does. They also would recommend Nmap, and their vulnerability scanner of choice, their highly recommended scanner is Tiger, which I only have very superficial experience with, but is very good. I use, as a matter of fact, OpenVAS, and I thought I had it on one of these screens, and maybe I've moved it or deleted it. But Red Hat also has a very nice security guide. They have chosen to continue to use SELinux, and they will continue to do that, although they have some unsupported availability of AppArmor. You're certainly welcome to use it. They just won't support you on Red Hat. And also AID and RPM. They also recommend Nmap. And they have stuck with their recommendation, the more traditional Nessus scanner, which is still very good. And I have not used Vlad. I have only seen Red Hat push it pretty heavily. So it might be good. You wouldn't know it from me. Other things to consider that we can't go into any great detail. System monitoring. If you're not monitoring your systems, whether it's one or many, you're at a great disadvantage. I recommend these. There are many others over and above these. You should also be looking at the logs, the syslog on your individual system. You should be spooling your syslog to a remote server. You should be keeping an individual syslog server for all of your different systems, pushing their logs there, and you keeping backups of that particular server so that you can remotely see what's going on without having to log into the box, tipping your hand to your investigation to a particular hacker, what you're looking at. I mentioned OpenVAS. We've been using this a great deal, both in terms of demonstration, but from a practical perspective at SUSE. And then this is kind of a mixed bag that we have here. I'm actually a very big proponent of Puppet. I use Puppet a great deal. I do demonstrations of Puppet, Chef, and I'm actually a big fan of CF Engine. I know Salt is very popular around here. This has pros and cons, though. If you are having centralized configuration management to manage all your disparate systems, if you have your Puppet server compromised, you've basically handed the keys to all of your systems. So, pros and cons with that. But certainly something for you to consider. Now, the transactions that take place themselves between client and server are quite secure, whether it's with PGP, GPG key, or with SSL. But those are good things to use.
Just monitoring, you got Nagios and Ganglia. Isn't Ganglia your Twitter handle?
It is. Sean, that's very perceptive of you. As a matter of fact, my nickname has nothing to do with the Ganglia monitoring system, but I have used Ganglia. I've deployed Ganglia in a number of different environments. When I was in high school, long before I was ever involved in open source or Linux of any kind, I was in a biology class, and Ganglia came up as being my nickname, and it's just stuck ever since.
All right.
Very perceptive. Of course, security often results in some sleepless nights. And that's not fun. You employ some of these principles that we've been talking about today, I think you'll sleep a little bit better. Maybe you won't sleep the best, but you'll sleep better. And you need to have fun. There's no reason for you to be doing this kind of stuff if you're not having fun doing it. So my encouragement to you is find joy in what you do and enjoy doing it. So that's my presentation for you. I appreciate you being here, and thanks for having me.
I have a question.
Sean.
You said if we can't get upper management to agree to maintenance patches outside the window, contact the vendor. You want to talk to management. What are you going to say?
we're going to explain to them exactly what we talked about here. And maybe the fact, you've probably been telling him or her over and over and over again, this is not the way that we need to be doing it. We've got to be able to apply these security vulnerability patches, and they haven't heard you. Maybe if the vendor has that conversation, they'll hear it differently. They may pay more attention. We just want to be as helpful as we can, be part of the solution, and support you.
Okay.
And I, in my organization at SUSE, we feel strongly that way, and we've had conversations with the guys at Red Hat. I can't say we've had the same conversations with the guys at Ubuntu, but we've had similar conversations with them. We feel the same way. We want you to be secure, and we want you to be successful. Otherwise, you won't be using the software for very long. Yeah. Any other questions?
What are your comments about GRSec or alternative security architectures?
Man, I was hoping no one was going to ask me about GRSec. I have not ever used it. I've used both SELinux and I've used AppArmor, and I've used neither. And I've done a lot of reading about GRSec, but have never used it. So I can't give you any practical advice. I can tell you that using GRSec is better than not using anything at all. And I do think that there are some very competent things that people are saying about GRSec. I'm sorry. Thank you. Well, thank you very much. Appreciate your time. Applause is not necessary.